All right, so today we are doing a review of APIs in web scraping. I'm just gonna go over some other, I'm not gonna do like the basics of APIs in web scraping, but through this, I will show you all 5 different examples of APIs in web scraping and some things that you might come across. Some of these might be also applicable to not just these APIs and websites, but others as well. Things to remember, pitch me your idea by Monday. Also, not everyone has signed up for their project review. I see some of you here who haven't yet. Just a regular 30-minute slot is good enough for the project review. I do have some last minute openings. I've cleaned up my calendar for tomorrow and Friday as well. So if you want to get it over and done with this week, which I do recommend, there are some new slots on my calendar. So feel free to book them. And you can totally let me know if you want me to cancel one that you've already made. Happy to do that as well. All right. Also, what else? Don't forget you have to do 4 blogs. I just have to keep saying that because I have had a bunch of students that finish their capstone projects and then have to graduate like a week later because they have to write 4 blogs. So please let me know. Yeah, I mean, not let me know, but please don't forget about your blogs. Cool. All right, so today we're going to go over some API examples. For the APIs, there are 3 that I'm going to go over. Twint for Twitter, Spotify for Spotify, and then PRaw for Reddit. Now, these data sources, I would say like Twitter and Reddit have a lot of data and a lot of text data, which you can use to build your own models. And you can pretty much collect data on a wide array of subjects. Like you can actually scrape a lot of like subreddit posts, for example. So I'll show you all that later. Now, all 3 of these examples are actually wrappers for APIs. Well, not exactly. Twint, I think I mentioned this with our last project, but Twint is a library that was actually written to really quickly scrape Twitter search results. So even though we set up all of this, it is actually running in their backend a script that scrapes Twitter. So that is an example of a wrapper because we are using abstractions of a scraper. If you look into their source code, they're just scraping Twitter. And for us, all we have to do is run this search. Now, a quick note about Twint. I was having some issues setting up Twint. I think a couple others as well. I've kind of narrowed down the issue to the version of Python that you're using. So for example, my Python over here is I'm using Python 3.9 and the Learn environment uses 3.6, which is a little bit more stable. So if you're using Learn environment, this should be okay. But if you run into any issues, Twint works perfectly fine on Google Colab. And if you're just running some Twint code or any of these other wrappers, you're just running the code to collect the data. It doesn't have to be in the same notebook as the body of your project. Which by the way, for your capstone project, you will be writing a lot of code. So you can definitely separate different parts of your project into different notebooks. I know some of you have already been doing that, but for this, it might even help make things a little bit more organized and clearer as well. All right, so with Twint, basically what it's doing is it's basically doing a search on Twitter and then scraping the results. So we have to import Twint, and all of these you just have to pip install. And if you want to pip install within your Jupyter notebook, you have to add an exclamation point, pip install Twint. Mine will say that is already satisfied, so that is good. For you all, yeah, just pip install whatever you need. Another thing that you have to pip install for some reason, and this is through too many hours of debugging, you also have to import Nest async IO. For some reason, at least on my computer, I don't know if on other systems this might be different. I haven't looked into the exact reasons why, but on my computer at least, I had to import this and use this .apply for it to work. Honestly, not sure why myself either, but that's how I got it to work. So how Twint works and how we will use it using this wrapper is we can give it a bunch of attributes in this search object. So here we're instantiating a config object to the variable C. And then with C, there are a bunch of attributes that we can add to it. So we actually take a look at the tweet attributes here. These are all of the things that we can customize. So for example, here you can see that some of the information that we have here, I'm looking for a search term. And if you just look up, if you want to do like multiple search terms or phrases, you can do that as well. But for simplicity's sake, I'm just going to look up all the tweets that have the word COVID. Now, Twitter, as you can imagine, has a lot of noise, like a lot of just random people tweeting random things. You have a bunch of bots on there as well. So in order to get better quality data, you can give yourself some parameter restrictions on the tweets that you do collect. So for example, in this case, I'm going to set the minimum likes to be 100. So that means a tweet has to have at least 100 likes for it to be collected. I'm just keeping count of the data. And for this quick example, I'm only going to collect 100 tweets. Another very important for us is that we set store CSV to be true, and we can output that into a COVID tweets CSV file. So over here, if you want to do other things, you can actually look at the dates. So for example, you can look at the dates, date stamp. I think these are different. Hold on, let me see where else there is. Never mind. Somewhere in here, I will look up that. Actually, if anyone's using Twit, just let me know. Or you can Google it on your own. You can actually set the date ranges. Now, something to note about Twit, and also with Twitter search, it does bias on more recent tweets. So let's just say you intend on collecting tweets over the past year about COVID. You're going to see a slight imbalance, and you're going to see a lot more tweets from like last month versus like the beginning of the year. So take note of that. So anyways, when I run this, I just tested this so it works. Sorry, this is just setting all the attributes, and what it takes to run is just .run.search_c. Now, while that is running, you can see all of this output. You might see some other outputs. If you're not seeing tweets come up, there's probably something wrong with the order that, there's basically something wrong with Twint. If you're running into any errors, my quickest advice is just to do it on Colab, because Colab, it works straight away. So just like this, I have 100 tweets with the word COVID in them. I can read in the CSV. The CSV is automatically outputted. Let me pull up my Jupyter home so we can take a look. So over here, you can see this COVID tweet CSV was just created seconds ago with all these tweets data. So just like that, if I read my CSV, take a look at the head, I have all of this information about tweets now. So here you can see that I have a bunch of things, but most importantly, the tweet itself. So if I do the tweet column, and you can see here, there's 36 columns. If you look at tweets.info, we have all of this. So there's a good number of null values, place, location, for example. Not every tweet has location data, but you can see how many likes it has, whatever hashtags, cache tags as well. If you're looking up like stock data, you can actually look up by cache tags, how many retweets, so on and so forth. Whether it's a retweet to something, all of this. But if you're doing like straight up NLP, usually just the tweet is enough, and the tweet is here. So with that, just do your NLP processes, clean this data, so on and so forth, and you should be good to go. You can also, as you can sort of see from here, there's a lot of non-English tweets. As of a few months ago, the language filter wasn't working. So what you can do is you can, I think they actually give you languages here. Hold on, let me see where it is. Yeah. So if I take a look at language, yeah, it doesn't actually, I believe it doesn't automatically filter, but you can always just collect a bunch of tweets and filter out the non-English ones if you'd like. You can also do your project in not English. That's also doable, but be ready to just explain a bunch of stuff to me. All right, any questions regarding Twint? All right. So next one I'll talk about is Spotify. And oh, by the way, Twint, you don't need any like API keys for Twint. It just works out of the box. So for Spotify, you do need an API key for Spotify. For Spotify. So Spotify is the Python wrapper for using the Spotify API. So there are two different ways through your Jupyter notebook that you can access Spotify's API. One, you can actually do like the request.get, very, very similar to how we were using it for the Yelp API previously. But Spotify exists, which actually makes it a little bit easier to use, not as many lines of code. And Spotify's documentation is actually very, very clear in my opinion. But for Spotify, what you have to do, you actually have to set up your own API key. And what you do is you just create an app on Spotify for developers. I should hide this, but yeah. So what you can do, you can just create a new app. With that app, it'll give you a ID and a secret, and you will need, well, I'm not going to reset that now. You will need that information to access the Spotify API. So this is one that I've been using for the past couple of years. I pretty much just use it to, I've done a couple of Spotify projects on my own and also use this to demonstrate Spotify. So what I do is you have to have a config file. If you don't remember what a config file is, we can talk about it, but basically it's just a Python file that stores all of your information. Don't forget, if you are creating a config file, you don't want this to end up on your GitHub. So if you have a config file, don't forget to add config.py into your gitignore, so this information does not get pushed to GitHub, because you don't want people to access your API keys. So I'm going to show you all Reddit later, but for Spotify, I'm just creating it as a dictionary, storing my client ID and my client secret. Setting up the Spotify to work, you're importing the config because that's where my passwords are. I'm going to just import Spotify, and Spotify, if you don't have it already, just pip install as well. And then the first step that you have to do is set up your instantiate your Spotify instance. I guess you can phrase it like that. So what I'm doing here, I actually took this off of their documentation as well. All you have to do is fill in your client ID and your client secret into this code over here, and that will run. Because I imported Spotify, because I imported config, here I have my module config. And if I look up that dictionary of Spotify, you can see that these are my two passwords for Spotify. If I can do the same thing for Reddit as well, but my Reddit has my actual Reddit password, so I'm not going to output that today. But from here, because it's a dictionary, that's why I can just call it like that. And it's actually inputting my ID and secret. So with Spotify, there are many different ways you can go about collecting data. One thing that I've done is I've actually done an analysis on my own Spotify library, only because I was curious. So what you can do is you can actually get your user ID. If you yourself have a lot of songs like playlists and stuff saved and you want to do an analysis of that, you totally can. But you actually can get your Spotify ID. So this is actually my Spotify ID. Look at the items and take a look at the playlists. So this is one quick way to do it. You can actually look at Spotify's documentation and see what are all the different things that you can get. So yeah, for example, you can get like artist info, you can get audio features. Audio features is actually really interesting. You can see like the different elements and characteristics of a song that Spotify actually saves all of that data really in a really cool way. But yeah, you can see playlist information, current user, what kind of, I'm guessing shows saved tracks, so on and so forth. Who's following the playlist things. You can actually create playlists through Spotify as well. So I've actually done, I mean, this is not relevant for this project, but you can actually create playlists on Spotify. I've done like an import from like Google Music onto Spotify by using their API. So that's actually really neat. I'll show you all the search in a little bit as well, because I think most people will be using the search if you were to use this API for the Capstone. But anyways, here I'm just taking a look at my own playlists. Over here, I'm just looking at the very first playlist. You can see that I have, what is this? Just a weekend song, I guess. So here I can actually see all my own data. This is cool if you're curious about your own library, but probably more relevant if you want to see, if you want to do a search, you can create a function using their built-in functions. So the way that, and this is really just by looking up the documentation. If I'm doing a Spotify search, you can look up artist and track. You can actually only look up artists as well. If you just want to do like an artist analysis or something like that, you can totally do that as well. Here I'm looking up three tracks. Here you can set whatever number you want, given an artist and a track. So with this function, I'm just, as an example, looking up this song, and I have up to three results from here of the song. These are basically, I think, all the regions and yeah, all of the regions that the song is available in, which is not very important. Also, you can search other things, like for example, you want to search a bunch of pop songs. You can do that as well. And I guess Lil Nas X is the first of the pop songs. So if you want to do a very, very general search for songs, you can do that too. I believe there is a limit. I want to say the limit is 100 songs at a time, but you can just run a loop and then grab 100, 100 and append it to a list. Cool. Any questions about this API? All right. So the next one we're going to talk about is Reddit, and Reddit has a wealth of text data. Those of you who use Reddit, you will know you can get any information, any post from a subreddit using their praw Python wrapper. I forget exactly what praw stands for, but it is open source. I think it's created by someone at Reddit, but using that, you can actually get whatever post data you want from Reddit, which is very cool. In setting that up, let's see, which tab is that? You just have to look up the Reddit prefs and the apps. What you can do is just create a new app. You create another app over here, give it a name, give it a description. It has to be a web app. Yeah, I believe it has to be, sorry, not a web app. It has to be a script, sorry. It has to be a script because then you don't need advanced credentials to access the information for personal use. So here I'm just calling it app test API practice. Basically, they give you personal use script. That is the like the ID. They give you a secret code over here. And for redirect URI, don't forget to put this here. What this means is that sometimes to use an app, you know how, for example, if you're using something that analyzes your Spotify data, and they will basically have you log into Spotify, it'll open up a Spotify window, let you log in and then close it out, and your data can be accessed from that third-party app. This is what that does. And so redirect URI, if you intend to use this within your Jupyter notebook, you basically have to redirect it into your Jupyter notebook. So that's what that is for. But with that, you can see over here, I have my ID, my secret, and this actually takes in your Reddit username and password. So I've already run it with my password, so I won't output this, but yeah. So with this, very similar, you have to set up the instance so that you can access the API. So here, this is just setting up the config with all the information. User agent being test, that's what worked for me. And then all you have to do is look up specific subreddits. So for submission in reddit.subreddit, basically means that I'm looking up this. So what this does is if I'm looking into the Learn Python subreddit, I'm just grabbing 10 of the whatever is the 10 top hot posts, I guess. So that's what that is. Right now it gives you a list object, but if I loop through that, you'll see that I get 10 titles. And pretty funny, they're talking about pandas data frames. All right. So here, as an example, if I coerce that into a list, I basically get a bunch of submission objects. And within these submission objects, you have a lot of attributes that you can pull out. So depending on what kind of information you want to analyze from Reddit posts, you can kind of pick and choose from here. So here you can see these are the different attributes. You can see like the author, whether it's been clicked, all the comments. So you can actually see, it gives you like a comment forest. So you can actually iterate through like comments and comments of, what do you call that? When someone replies to a comment, you can actually look at that. You'll see like the post itself, that's the self text. Yeah, all of this information. So from here, I'm just doing this in a very, very quick list comprehension. Let's just say I want to look on the news subreddit and get the ID, title, URL, and score. And once I have that, if I coerce it to a data frame, I'll see all of this. So this ID might be important. You might want to use it for searching up more information about the post later on, or maybe you want to use it as like a join tool. It's always good to have some sort of identifier. But here you can see that I have the title, URL and the score. I forget what the score is. I think might be like, is it the upvotes? I personally forget, but oh yeah, number of upvotes. But yeah, so that is the Reddit API. And in the past, a lot of people have used Reddit data kind of either in conjunction with or instead of Twitter data, because I think it's a little bit less noisy, but you also run into the issue of Reddit posts are on average a little bit longer than tweets. So kind of up to you what kind of data you want to deal with. Yeah, any questions about this before we move on to a couple web scraping examples? All right. Okay, so for web scraping, there's a couple things I want to talk about. First one, I want to talk about XML formats, which is very, very similar to HTML, but we'll get to that in a bit. And then also dealing with data consistency, and that will be in the next example. So here, I'm going to be doing a board game example, and this is from the website Board Game Geek. If anyone's like the board game aficionado, you probably know what that is. I honestly didn't. I worked on this project with somebody else, but yeah, they have an API that actually works like a scraper. So XML is a format that precedes JSON. So if you see XML, and XML actually looks like, actually, let me copy this URL. Hopefully we can see it. XML looks like this. It looks a little bit more similar to HTML, but functionally works just like JSON. Older websites typically, and older APIs are in this XML format. So if you see like the triangle brackets, those are more XML. All right, so going back to this, this is just, I'm just showing you how to iterate through XML. So the way that you do this is you have the URL, and this URL is from their API documentation. If you remember, we always do .content to get the information, or .json if it's an API. But in this case, we're actually going to parse it through Beautiful Soup with the XML parser. If you remember for other examples, it is, I believe, where is it? Where is the Beautiful Soup? We parse it through HTML. I guess that's the default, so it's not in here. But from the example that we talked about in our phase 1 study group a few months ago, we used an HTML parser. The difference here is we're not doing HTML anymore. We are doing XML. So from here, oops, let me import this. There we go. So from here, we're just finding each item. And I know to look for item because item is here. What's nice about XML is that if you actually copy and paste any URL from even an API call or, yeah, actually this is technically an API call, you'll actually get this output. So from this, I can take a look at the item. Here, I'm only looking at one item. I know that if I change this ID, it'll give me a different thing. Hold on, here. This is a different game, but what was I talking about? Anyways, here, I'm just looking at the item and games 0, if you remember, find all returns you a list. Even though there's only one thing, it will still return it to you in a list. So game 0 will give me that first game. So you see there's a lot of different attributes there. So within this, you can run find or find all on these excerpts. So if you remember, I called them mini soups before. So as you're iterating through things here, for example, you can see that there are multiple names for this game called Samurai, probably different names in different languages. So to do that, if I want to find all of the different names, I get this. And then from here, I can also loop through and get like the value, for example. So let's just say I want to get this specific thing. It works just like a dictionary as long as it's within the same triangle brackets. So here, I'm just looking at value. That gives me the name over there. If I want to get whichever the 5th one is, that's what that is. But yeah, working through this, it works very, very similar to a JSON file. It just takes a little bit of getting used to. For example, here, we're grabbing the type, then grabbing all the different names. Let's see, what's over here? Yeah, all right, I guess this is just the first one. We're just looking for a name that is the primary name. So that's that. And to get other things, you can get the description, so on and so forth. Depending on what data you want, I would say if you're working through like a web scraping example or a large JSON output, take the time to explore and see what kind of information they are providing you with to begin with. Cool. Any questions about this? This is really just to show you that if you see XML formats that look like this, it's fair game as well. All right. The last example I'm going to talk about is using Craigslist, and we're going to talk about some things that you shouldn't do when you are web scraping. So this example, we're just going to look up apartment information. So actually, let me pull this up to show you all what this website looks like. This is just, I guess, places for rent in the New York area. So we're just going to try and scrape all of this information. We're going to start simple for now. Let's grab the name of the listing, the price, and also the neighborhood. So we'll start with that. Okay, so as you know, we're just going to feed it in the URL and parse it through beautiful soup. And then we're going to get each apartment. And I know that because I looked through the soup. So if I take a look at soup over here, or actually instead of that, we should look at it here, inspect. And you can see that each thing or each result is within one of these, is within a result row. Let me reorganize this so it's a little bit easier to see. All the information is contained within result row. So if I ever wanted to get like the image or whatever within this, if I wanted to get like the URL for the listing, I can get that out of here too. So cool. That's how I know that each apartment will be looked up using this search term. So cool. If I look at apartments, this is what I get. I know it's going to be a list because I use find all. If I just take a look at that first one, this is what one apartment looks like. So as you can see, I think this is the title. If I wanted the URL, that's there as well. The price is here too. And result hood, that's the neighborhood too. So all the information is contained in here. So yeah, kind of did this already. First, the first result is here, and that was the first apartment. Cool. So one way that you can do this, and I'll tell you why that's not safe. One way you can do this is get each attribute at a time. So let's just say, all right, I have these 20 mini soups for each apartment. So each element in this list is the data for an apartment. What I can do is loop through that. So let's just say, okay, I just want to get all of the titles and all of the prices. Cool, simple enough. I looked it up and found that all of the titles are under this class. All of the prices are under this class. So cool, I ran that, but you can see that I ran into an error over here. So we'll deal with that later, but we ran into an error. So therefore this didn't work. Seems that there was a none type in one of the prices. So one of the prices was a none type. If we put in like a try except or if not none, that can lead to complications. I'll show you all why. If I change it to this real quick and we look at length of titles and we look at prices, if we look at the length of prices, it should also be 120. Cool. The issue with doing this is what if the loop that you wrote led to 120 titles, but like 110 prices? If we're missing 10 prices and we did it this way and we wanted to like put it into a data frame separately, you run into issues because if you have missing data somewhere and you're doing it column by column, it's very hard to figure out which listing we're missing the prices for, as an example. So a safer way to do it is to actually do this all at once, which I don't have over here. So as a quick example, neighborhoods. Neighborhoods doesn't have, has some none types as well, which is why you have this. So instead of doing that, what you should do is, let's see, if we do prices, is like this, and then we do something like this. If results equal to none, we're going to do that. We can do price, this, and then we can do prices dot append price. Oops, just kidding. None for this one, and then prices dot append I don't think that's going to work. I think I have to look into it more. But you'll see that the DF will probably have like null values or missing values. Okay, see how we have 2 missing values for price? That's what that's all about. And then, yeah. Moral of the story is to be consistent when you're collecting your data. It's better to do it row by row versus column by column. So careful when if you're scraping data to not do that. Cool. Any questions about this or like the concept of what I talked about? I don't know if that was super clear, but happy to take questions. All right. Additional things to explore. These are actually not part of our curriculum, but some people have found it helpful in collecting their data. So first I'll talk about Scrapey. It's just another library used for scraping. Some people prefer it to Beautiful Soup, but it actually came out after I graduated from Philadelphia High School, so I personally haven't touched it at all, but a bunch of students do like Scrapey. If you're like really annoyed at Beautiful Soup and you need to scrape some data, maybe check that one out. Another thing that you can try is this library called Selenium. So sometimes if you have data on a site that is one of those like auto reload sites, if you know what I mean, like, you know, those websites that when you scroll down, then things will turn up. That's hard to find in the HTML. And sometimes it is not written in HTML. It could be using some weird like interactive elements that don't show up in HTML. If you want to get that data, Selenium is a library that basically allows you to control your mouse and keyboard. You can actually tell it, all right, scroll down to the bottom of the page, let it load, scroll down to the bottom of the page again, let it load, and then get all of that data. So Selenium, there's a bit of a learning curve, but you can definitely use that as well to collect your data. There are a lot of Selenium tutorials on YouTube and on Medium as well. So I don't think it'll be hard to pick up. And I've used it a couple times, so happy to help debug, though not my area of expertise. But yeah, hopefully that was helpful. If you decide to use any of these APIs or websites, feel free to take this code, except for this last one, because that's an example of what not to do. But yeah, cool. Any follow-up questions to scraping before I stop the recording, and happy to take other questions. Going once, going twice. All right, in terms of like when is a good time to have your data by, I would say like try to have your data by like early mid next week, or at least be in the process of collecting it. Remember, no like off the shelf data sets. And if you're not sure whether a data set is okay or not to use, ping me and let me know. All right, let me stop the recording over here.